Hello students, it looked like some of you were having some trouble with this week's assignment, so I'm making this video as a little extra help. So the normal rule just helps us find the necessary sample size to get a normal distribution. Alright, and if you remember from the video, the normal rule said we needed at least 10 successes and 10 failures. So let's take a look at this question. At the start of fishing season, the true proportion of adult fish large enough to keep is 0.324. What is the minimum number of fish that you would need to catch to pass the normal rule? Alright, so we need to find probability of success and the probability of failure. Alright, so the probability of success is 0.324. That means the probability of failure is 1 minus the probability of success. So it's 1 minus 0.324, which will give you 0.676. Double check that real quick. Yeah, that's good. So that means what I want to do is I just want to solve the equation that the probability of success times my sample size equals 10. So that's 0.324, n equals 10. Then n equals 10 divided by 0.324, which I will put in my calculator. 10 divided by 0.324, and you'll get 30.8642. And since I can't do a part, I can't do 0.8642 fish, so I have to round up. Always round up. Now that's only for successes. Let's see for failures. So again, this would be the probability of failure times n equals 10. So that's 0.676 times n equals 10. So n equals 10 over 0.676. Put that in my calculator. 10 divided by 0.676. And you'll get 14.793. And again, we can't have 0.793 tests, so we would have 15. Now, which number am I going to use? Do I have to do 15 trials or do I have to do 31 trials? All right, well, this is the larger number, so we're going to have to do that. Because if I did 15 trials, I'll get 10 failures, but I won't get 10 successes, right? I would get this, if I go 15 trials, I'll have 10 successes, 10 failures. And that means 10 minus 5 is 5 successes. And that's not good. We can't have 5 successes. Whereas if I do 31, that would give me 10, looking up here, successes. And then 31 minus 10 failures, which would be 21 failures. Because both numbers are over 10, we know that this is the value we want to use. Move this out of the way. So therefore, we require a minimum of 31 fish in our sample. So that's what we're looking for. Let's take a look at the, let's see if this one, this example passes the normal rule. So a pharmaceutical company wants to test a new treatment that helps prevent smelly feet. If the true proportion of people who react positively to the treatment is 0.623, what is the minimum number of people that they will need to test to pass the normal rule? Okay. So the proportion of people who will react positively is 0.623, so that's our probability of success is 0.623, which means our probability of failure is 0.377. So again, we want to solve the probability of success times our sample size equals 10, and the probability of failure times our sample size equals 10. So that's 0.623n equals 10. So n will equal 10 divided by 0.623. Put that in my calculator. And I'll get n equals 16.05. Now the interesting thing here is I can already tell that this one's not going to be the right answer. Without having to solve for this probability equation, I can tell this one's not the right answer, because this doesn't allow me to have at least 10 successes and at least 10 failures. I would need, so I'd have 10 of one and 7 of the other. So they're not both at least 10, so I know it's not going to be that one. At the end of this video, I'll explain. I actually knew it from the very beginning. And probability of failure, so that's 0.377, n equals 10. So n will equal 10 divided by 0.377, which I put in my calculator. I'll get n equals 26.52. Now this one is going to work because I will have 10 failures. And again, we will round this up, and 17 successes. Since they're both 10 or greater, we know this is a good amount. So then therefore, I will need to test at least 27 people. So I hope this video is helpful. Good luck with the rest of the assignment.